How many digits should be in your answer? This is an introduction to significant figures. I've kind of mentioned significant figures in a few videos, but now we're going to get to the nitty-gritty, the nuts and bolts of significant figures and what that means for calculations. All right, so here are the objectives. Pause it, read them if you want. Trust me. Okay, first, accuracy versus precision. What do these mean? So accuracy is how close a measurement is to the true or actual value, and precision is how repeatable the measurement is. Okay, so I could measure the mass of something and continuously get 10.1, 10.2, 10.2, 10.1. But the actual mass is 8.3. So although my measurements were precise, they were repeatable, they weren't actually accurate. All right, so you should have both. So close to the correct answer, accurate, but also repeatable, precise. All right, so here's how we're gonna test this in class. So we're gonna need a ruler and an index card. So I have those supplies for you in class. You're gonna measure the length and the width of your index card, and you're gonna measure in centimeters. And you'll write the answers literally right on the index card. Okay. And now let's look at our measurements. So which digits are you certain of? Which digits are you uncertain of? Okay, so the package of index cards says the length is 12.7 centimeters, the width is 7.6 centimeters. Now I want you to calculate the percent error for the length and width that you just figured out. So this is tying to a previous lesson, but also kind of discussing measurements and what uncertainty means. So what do I mean by uncertain? So which digits are significant in a measurement? So all of the certain digits and one uncertain digit. So how do you remember it? It's literally the last digit. And I'm going to give you some examples of that later in this PowerPoint, and then hopefully it'll make more sense. So remember, the last digit in a measurement is uncertain, but it's still significant. So here's the easy rule. All digits 1 through 9 are always significant. So you just count digits. So let's just pull this up. So how many significant figures are in here? So I look, this is not a digit 1 through 9. So only one that's weird is 0. Not a 0, not a 0, not a 0. So I count 1, 2, 3. That's it. 3 significant figures. I don't see any zeros. I just count 1, 2, 3, 4. No zeros. I just count them. 1, 2, 3. No zeros. I just count them. 2. Okay, so now remember, the last digit in a measurement is uncertain. So this 5 would be uncertain. This 3 would be uncertain. This 4 would be uncertain. And this 9 would be uncertain, but still significant. The only exception is if you count it. So if I counted 17 students, all of those digits are certain because I literally counted it. All right, so if you're counting, it's significant. But if you're measuring, the last digit is uncertain. All zeros that are sandwiched between digits 1 through 9 are always significant. So how many significant figures here? So look, I see a 0, but it's in a sandwich. It's between a digit on both sides that are 1 through 9. So I just count them. 1, 2, 3, 4. 4. I see zeros, but they're sandwiched between non-zero numbers. So I just count 1, 2, 3, 4, 5. I see a 0, but it's sandwiched between non-zeros. I just count the digits. 1, 2, 3. I see zeros, but they're sandwiched between non-zero numbers. So I just count 1, 2, 3, 4. 4 significant figures. Remember, all of the digits except the last one in a measurement would be certain. All of these are certain. The 6, the 0, the 2, those are certain. The 3 is the uncertain digit, but it's still significant. So here the 3, uncertain, but significant. The 4, uncertain, but significant. And the 9, uncertain, but significant. Now, if there are no decimal point, there's no decimal point. Zeros at the end, right side of a whole number are never significant. So look here, I see zeros. Okay, they're not sandwiched. They're at the end of a whole number. I don't see a decimal point, it's at the end. So these zeros are not significant. So I only have this one right here, 6. I only have one significant figure. So I look here, no decimal point. I have a 0 at the end of the whole number, ignore it. So I have a 7 and a 3, so I have 2 significant figures. I look here, I have a 0. This 0 is sandwiched, that's easy. This 0 is at the end of a whole number, no decimal point, ignore it. 1, 2, 3, 4. Okay, here I have a whole lot of zeros. They're not sandwiched. They're at the end of a whole number, no decimal point. So I ignore them all, and I just count the 1 and the 2. So I have 2 significant figures. Now, if there is a decimal point and zeros are at the end of the number, they are significant, okay? So I see zeros, but there is a decimal point. So to the right of the decimal point, those zeros are going to be significant, okay? So if the zeros are coming after a number, right? So here's a non-zero number. The zeros come after that number with a decimal point, they're significant. So 1, 2, 3, 4. 1, 2, 3, 4. Because I have zeros, but they come after, to the right of non-zero numbers. So they're to the right of a number. They're significant. 1, 2, 3, 4. I have zeros, but they're to the right of a number, and there's a decimal point. So 1, 2, 3, 4, 5. And I have a 0, but it's to the right of a number, and there's a decimal point. So 1, 2. Okay, now if there's a decimal point, place holding zeros, like the ones at the beginning, it's just like 0 point, those don't count as significant figures. They're not significant figures. So those placeholder, those leading zeros are never significant. So look here, I have a 7. I know that's significant. And then I have some zeros where they're not sandwiched. They're not to the right side of the 7. They're to the left side of 7. All they're doing is holding the place. So they're not significant. So only the 7 counts, one significant figure. Here, I have zeros. Well, this one is to the right of a number when there's a decimal point, counts. But these two are placeholders. They don't count. So 1, 2. Here, there's a whole lot of zeros. There is a number, the zeros to the right of the number because they're a decimal, they count, but all of these placeholding zeros get skipped. 1, 2, 3. Here I see zeros, but they're placeholders. They're to the left when there's a decimal and they're not sandwiched. So I have 1, 2. 2 significant figures. All right, so let's read this balance. What do I have? So I have 272, okay, 0.1, 0.2, 0.3. So I'm reading it as 272.3, and I'm going to say 0.5. Like that's halfway between the 3 and the 4. Okay, but which digit is uncertain? That's the 5, that last digit right here, this one. Why is that uncertain? Someone else might record this as 272.34 or 33 or 36. This is where there could be variability. We should all have these digits the same. Those are certain. This last one is the estimate. It's the guess. This one could be different. So when you looked at this, you may have had a different number here. The rest should have been the same. So how many significant figures does it have? Well, those are all not zeros, so it's 5. All right, so let's read this balance. So we have 190. Okay, so 0, right? So 190 point, all right, my measurement is 0.40, because look, you can see 0.2, 0.4, 0.6, 0.8, that's 1. So each line is 0.2, and it's on the second one. So what digit is uncertain is the last digit, the last 0. How many significant figures? All right, well, I have a sandwich 0, that counts. And I have a 0 to the right of a number. And there's a decimal point, so that one counts. So there's 5. All right, so let's read this thermometer. So 80, 81, 82, 83, 84, 85, 86, 87. So 87 point, and then I'm going to make an estimate. So I say 87.5. Which digit is uncertain? The 5, because someone else might say 87.6, 87.3, 87.7, whatever. Okay, so how many significant figures? Well, there aren't any zeros, so 3. Let's read this thermometer. So 10 up through, so 15, 16, 17, 18. So 19.6 something. I say 19.3, but which digit is uncertain? That 3, because someone else might have said 0.2 or 0.4. How many significant figures? No zeros. They're all significant, so I have 3 significant figures. Okay, let's read this ruler. So I have 1 centimeter, 0.56, so 0.6. So 1.6 something, and I'm going to estimate. So I say 1.65, but which digit is uncertain? That 5, that last number, it could be slightly different based on who is doing the reading. How many significant figures? No zeros, so they're all significant, so that means 3. All right, so let's read this ruler based on D. Okay, so 5 point, I said 30, so it's right on that line. Okay, that's what I said. All right, which digit is uncertain at 0? Maybe I'm wrong. How many significant figures? 3. Why? There is a 0, but it comes to the right, okay, of a non-zero, and there's a decimal. Okay, so here's some practice. Here's a short way that I do it. First, I look at the number. Is there a decimal point? No. So what I do is I start on the right side of the number, skip any zeros I see, and once I get to a number that's not a 0, I start counting and then keep counting. So no decimal, start on this side, skip 1. Okay, so no decimal point, start on the right side. As soon as I get to a number that's not a 0, I start counting. Okay, well, I'm not a 0. 1, 2, 3, 4. Okay, now when there is a decimal point, so see here how there's a decimal point? I'm not going to start on this end. I'm going to start on the other side and start counting as soon as I get to a number that's not a 0. So 1, 2, 3. There's a decimal. Start on this side. 1, 2, 3. There's a decimal. Start on this side. Oh, the first thing I see is a 0. Skip it. Skip it. Now count. 1, 2, 3. Here's a number, no decimal. Start on this side. 1, 2, 3, 4. If you do it this way, you don't have to remember all those rules. Sandwich zeros, right side, left side. If you just remember, when there's a decimal, you start counting on the left side. When there is no decimal, you start counting on the right side. When do you start counting? When you get to a not 0. So let's practice again. So there is a decimal, start on this side. That's not a 0, count. And then you can't stop counting once you start. 1, 2, 3, 4, 5, 6, 7. There's a decimal, start on the left side. Not a 0, start counting. 1, 2, 3, 4, 5, 6. There's a decimal. This is not a 0, start counting. 1, 2. There's a decimal. This is not a 0. Oh, actually, it is a 0. So skip it, skip it, skip it. Now count. 1, 2, and you can't stop. 3. Once you start counting, you can't stop. Okay, so in class, we'd be doing a Blue-Ket, super fun. If you've not tried Blue-Ket, give it a try. So there you have it. There's an introduction to significant figures, and I hope you learned something new.